Okay, hello everybody again. Sorry about that. We just learned a lesson about running Google Hangouts. I think we won't make that mistake again. But my bad, and I should be able to start right where I left off. So bear with me just 1 second, and we will get back to our presentation. I was saying to you that we have an all-star cast of instructors. Dave Wagner from Northern Arizona University, Yoshi Nakasawa from the CDC in Atlanta, Abdallah Sami and Lindsay Campbell from the University of Kansas here with me, and Luis Escobar from SUNY Upstate University in Syracuse. These are all people who are active researchers in this field, and so I'm very, very happy to have them here as part of putting together this course. So how will the course work? Again, the plan of the course, which is to say the syllabus, is available at this Google Doc, and that is posted both on the Facebook page and the Google Plus event. The Google Plus page is where we will put up the link to every segment of the course and send questions to the speakers to the email address that's given below, biodivtraining@gmail.com. If you send your questions to those, we've got time periods set aside throughout the course where we can answer your questions. So just bear with us, and we will do our best to get to your questions. So that's the plan for the course. Now we're going to go on to a second presentation. Sorry, by me again. I'm going to get through this in about 20 minutes so that we can get on to our exciting third presentation, which is by Dave Wagner. But I just want to give you a quick introduction to the challenge of mapping disease transmission risk, which is to say, what are we talking about when we're talking about mapping transmission risk? So I just Googled the idea of disease risk, and I came up with this very interesting map. It's from the WHO, and it's a map of environmental burden of disease as percent of total disease burden. So as I understand this map, it's essentially a map of where it's dangerous to be a human. And for our participants who are watching from Africa, sorry guys, looks like you're in a dangerous place, followed by those from Asia and then those from America. I'm not sure I understand what this map means, but somehow this is the risk of disease. So I went a little deeper in that site, and here are deaths per million from vector-borne disease. And again, Africa, Asia, America is the approximate ranking. But also notice that this is a pretty coarse level summary. Is every place in India at 20 to 50 deaths per million from vector-borne disease, or are there differences across the country? Which is to say, what do these maps mean when they color an entire country the same level of risk? And then this was my favorite of the WHO maps, deaths from climate change. And I was really trying to figure out how a change of 1 degree, which is about what climate has changed in the past few decades, how those deaths are attributable directly to climate change. And so a big thing that we're talking about in this course is getting a little more specific than climate change or vector-borne disease or environmental disease burden. Trying to get a bit more specific and go within a country to be able to talk more intelligently about risk across geography. So then I looked at a finer scale. And so I started looking at Lyme disease, which is a zoonotic disease, that is spreading across, or is present across, various areas of the U.S. And Lyme disease has these two strange foci. I'm going to share and unshare my, for some reason it has frozen on us, which is bad. So here I am again. And let's share this once again. And hopefully this time it will share. But this is a Lyme disease risk map. And you can see it categorized as high risk, moderate risk, low risk, and no risk. And so that's very interesting, and you can see quite a bit of heterogeneity in levels of risk. But then you can also see strange things, like look at the state of California, where almost all of California is listed as low risk, but then immediately adjacent parts of Nevada, Arizona, and Oregon are no risk. So that just looks a little odd to me. I'm hoping that my slide has advanced. Here are two other risk. One of them is in terms of infected ticks, and you can see that they are listed as abundant, common, rare, or none. And then yet another is cases of Lyme disease, and you can see this map consists of random points plotted within counties where people have gotten Lyme disease. So I've just shown you three very different ways of mapping risk of Lyme disease within the US. So what are we mapping when we talk about mapping disease risk? Is it numbers of human cases? Is it probability that a single human would get infected if that human were in that place? Or are we talking about infection rates in vectors or hosts? All of those are possible definitions, but too often those definitions are either lacking or they're uncarefully laid out for us. I'll give you some examples. Here is a revised global yellow fever risk map and recommendations for vaccination in 2010, again from the WHO. Sorry, people from the WHO, I'm picking on you today. But I just want you to see some of the maps that they present. Here's a map of Bolivia, where you see endemic areas in orange and no-risk areas in gray. And it's all a question of whether the site is above or below 2,300 meters of elevation. So that's nice and quantitative, and in a GIS it's very easy to produce this map. But does that mean anything? Really, do you go from zero risk at 2,299 meters to an endemism of yellow fever at 2,301 meters? Or is there some detail involved in this that we're not seeing? In the same document, we see another mapping of yellow fever risk based on vegetation cover. This is for the country of Niger. And essentially what we're seeing, again, is risk areas shown as grasslands, croplands, and we're hoping that this presentation continues live. But essentially, we're seeing mapping based on vegetation cover. But we know that yellow fever risk corresponds more to mosquitoes and their transmission of of this zoonosis. So what I'm after is that this risk pattern is maybe a little bit more complicated than how we're talking about it. Here's another example towards a Kala Asar risk map for Sudan, mapping potential distribution of phlebotomists. So here is a map of risk of this disease in panel D, and notice that it is based on the probability of presence of the vector. Now, is that enough? Here's mapping the population at risk of sleeping sickness. And this is one of my favorites as far as the assumptions that go into this endeavor. What do we see when in this publication? Well, they take each case and they plot its geographic position. That's what this mound is showing. And where that position is, they then take a 30-kilometer radius around that and create a probability density distribution around that area. Well, then they plot all the cases simply in terms of those probability density distributions. And so their final map looks like this. Again, I'm hoping you're seeing this. I think you are. But what do we see but observed cases across Central Africa? And it looks like an impressionist painting when they were using the Pontygist style, and they would put a splotch of paint and eventually create an impressionist image out of those splotches. Well, do you believe this? What do those gaps in the map mean? These places where I've plotted question marks, do those really, really have zero risk of transmission? I don't think so. Rather, those may be sites where there's no monitoring or no reporting. Look at the South Sudan border compared to northeastern DRC. Is that really an interruption of transmission, or is it an interruption of reporting and cases? Here's another example, risk maps for Lassa fever in West Africa. And here we see cases as blue stars and mapped risk in red as opposed to green. And what I want you to notice is that risk clusters around the areas where we have data. And that's a little scary. That's some sort of interpolation that appears to be overfitting to where the data exist. So we have lots of different definitions and approaches, but we see relatively little that's based on conceptual foundations. And so maybe what we need is a new orientation. If we could build our maps of risk based on principles of ecology and biogeography, if we could build our view of zoonotic disease and transmission as a set of interactions amongst species, maybe we could get to a new and deeper level of understanding. That's the focus of this course. So the ingredients are spatial distributional information on hosts and vectors and pathogens. We need detailed information on environmental variation across that region. We need inferential analyses where we link the occurrence information to the environment, and then we need to put together the different components of the transmission system in an estimate of risk. So that's where we're headed with this course. I apologize for a few of our technology gaffes to begin, but we are off to a running start. We'll be back in 7 minutes with Dave Wagner. We will post the link for part 3 of this course in just a moment on the Google event page. And we hope to see more and more of you back as Dave starts his talk. So please come back in a few minutes, and thank you for tuning in.